Hello, welcome to the Canadian Global Energy Forum's latest in a series of webinars, today focusing on helium exploration in Canada. My name is Curtis Everett. I'm the co-founder and a director of CGEF, and I'm currently Vice President Exploration of Shared International Corporation. It is a pleasure to see over 200 attendees, not only from Canada, but also from 28 other countries around the world. Our series of webinars truly has global reach. Thank you all for attending. Before we start, I'd like to give you some information regarding this webinar. Audience questions will be answered at the end of the presentations. Please submit questions via the Zoom Q&A button on the bottom of your screen, and we will attempt to answer as many questions as time permits. The recorded webinar will be posted online on the CGEF website at www.cgef.org within a few days of the presentations. For those of you not familiar with CGEF, we are a volunteer-led organization of Canadian-based, internationally focused energy companies. Pre-COVID, we hosted bi-monthly luncheons and an annual conference in Calgary. We are now happy to be hosting a series of webinars focusing on various energy topics and exploration areas. CGEF has recently changed its official name from the Canadian Global Exploration Forum to the Canadian Global Energy Forum, still referring to us as CGEF. This reflects the changing world during this energy transition to expand our focus to include a number of other energy sources, including but not limited to geothermal and hydrogen. Today, our webinar is focusing on the emerging helium exploration industry, primarily in Canada, but applicable internationally. Helium is a critical gas that is used in a number of different industries, and not just for filling balloons and blimps, but from the medical industry to semiconductor manufacturing to ultra-cold applications such as quantum computing, just to name a few. Over the next years and decades, there will be an even greater demand for this gas. We are pleased to have with us today two speakers who are part of a team exploring for helium in Canada. I would like to introduce our first speaker.
My name's David Johnson. I'm an exploration geologist. I've spent most of my career exploring one way or another. I started out in exploration with Shell, with ExxonMobil, and with Husky here, and then did a startup of my own, and then went to Kuwait for a while with research projects, and with Cuffbeck over there, came back and teamed up with a group over here looking at helium, beginning to understand about helium and the helium potential that's out there. And so I've been exploring for probably over about 40 years now in about 40 basins around the world. And but helium we've been doing for about 4 years. And it is just a tremendously interesting topic as we move forward. Helium is just absolutely vital to life as we know it. And I'm going to take you through some of the pieces of that and why it is. And what I hope to take you through here is some of the, essentially some of the uses and some of the costs associated with it, how we produce it, where it comes from, and what the market looks like, some of the supply and demand issues, so that you get a grasp of the entire of the industry on an overall sense. I am open for questions, and I'm available afterwards. If anyone's interested in helium and wants to know, please feel free to contact me. So it is a vital emerging industry. It truly is. So let's just a little bit of a lag here. So, okay. Just get the control. There we go. All right. So the helium market. So the global demand for helium is about 6.3 billion cubic feet of helium a year. And that's a 2018 number. The number has grown significantly since then and will continue to grow. Now, I've broken out the pie chart here just so that people can understand most of the sectors of this have to do with the unique properties of helium, and I'll explain them as I go through them. So about 30% gets used for controlled environments. So when you're manufacturing a silicone chip, computer chip, it's silicone, and the way you etch the chip is using hydrofluoric acid. If there is stray atoms of oxygen in there, the hydrofluoric acid will go where it's not supposed to go, and that spoils the chip. To prevent that from happening, you flood the environment with helium. Now, helium is inert. It's one of the noble gases. It's the upper right-hand side of the periodic table there, and it won't react with anything. So it is used essentially to create that pure environment. And so it's used for the semi-chip applications. It's used for generating fiber optics. It's used for high temperature arc welding. It's used in aerospace applications for essentially purging the tanks, and you can't afford to have something that's reacting with the gases that are actually being used for rocket fuel. So about 30% of it gets used in that process. About 21% of it gets used for research and medical applications. So helium is the very last thing to become a liquid at 1.15 degrees above absolute zero, the temperature at which all molecular motion stops. So it is the last thing to become a liquid, but it also, when it reaches those temperatures, it becomes a superconductor or a superfluid. And what that means is that it is essentially frictionless, which means we have the ability to create pure frictionless environments on Earth from an experimental perspective. And you can understand that that's hugely valuable. Within the medical industry, it's also finding increased usage. Current use right now is HELOX. Helium, because it won't react with anything, can be used in the body without harm of damaging it. So when you mix it with oxygen, you create a helium-oxygen mixture. And then a person who has COPD, that has trouble breathing, what that does is it basically reduces the viscosity of the air gas mixture. So laminar flow is achieved in the lungs. So a person can breathe more easily. And this has applications for COPD or people with problems that come out of COVID. About 21% of helium is used for cooling and cryogenic purposes. Now, everything has a capacity to hold heat. Helium has a huge capacity to hold heat. But on top of that, it expands dramatically very quickly because it is such a small molecule. And as it expands, it cools. That's called the Joule-Thomson effect. So it has a huge capacity to take on heat and then carry it away and dispel that heat, which makes it unbelievably valuable for things that generate a tremendous amount of heat. Literally, every MRI machine uses helium because of these properties. If you were to try and cool an MRI machine using other things, you'd have to have a cooling plant that's about 1,000 square feet in area. I mean, it has to be big. Helium is just that much more efficient at it. So most of those industrial applications that I've just spoken about, the 30, the 20, the 21, about 70% then, these require pure helium, 99.999% pure for most of those applications. The next application we're all familiar with, blimps and balloons. So helium is 13.6 times lighter than air. It's one of the two things that we can use to lift us off the Earth without propulsion. The other one is hydrogen, and it tends to explode. And I'll have some comments about that later. So there are challenges with that, but 13.6 times has a huge lift effect. So balloons and blimps, obviously. And then leak detection. Helium is actually the smallest molecule. That's smaller than the hydrogen molecule. And the reason that is that the nucleus is 2 protons and 2 neutrons. So the nucleus is denser than a hydrogen molecule with 2 protons. And so the electrons circle closer to the orbital, making it the smallest molecules. So it's used for leak detection. So if you're commissioning a plant, you want to find out where the leaks are, you basically flood the environment with helium, and it won't react with the fluids, it won't react with the metals, and it will tell you where the leaks are. There we go. Hello. Speak to me. There we go. Now, the price history on helium is fascinating. Helium in an industry really grew up out of the United States, where the US basically had a monopoly on helium globally, basically out of Texas and Oklahoma. And the government of the United States actually owned the resource. So they were selling it in public auctions through the Bureau of Land Management. And this was the norm. And and companies would come in and bid on lots. Well, as the industry grew, 4 major industrial gas players came to dominate that space: Prax Air, Air Liquide, Lind, and Air Products. And so as we move in through 1998 and into the 2000s, you basically have 4 major players that are bidding on lots in a public auction. And this is the price history that we see. And it's really flat. It's really calm. Nothing changes much at all. Around in the early, 2010s to 2013 period, the government of the US recognizes that they can't supply the world with helium, that there's going to be a shortage for them. So they say, okay, when our reserves reach a certain level, we will say this is the last sale. And we'll do that under the Stewardship Act. So the 2013 Helium Stewardship Act sets this into law. And by 2020 something, we'll all be out of the BM Bureau of Land Management, will not be selling or managing helium anymore. So 2013 comes, and we see that there's this big drop. So this is 2.1, okay, billion cubic feet of helium. That's what we're looking at here. And this is going to drop down to 0 by 2019, 2020. The last sale occurs in 2018, and the price of helium takes off. It goes from somewhere around a little over 100 up to about $337 per 1,000 cubic feet. That's for 1,000 cubic feet, and that's raw helium. So compare that to this is natural gas from, well, we'll wait to see. It's better now. Anyway, so it is much more valuable than natural gas. So it is basically this small volume, high value commodity. After this period of time, basically the public land sales, the public gas sales are no more. So we enter an opaque period where the price of helium is locked behind non-disclosure agreements. So unless there's press releases, there's no way to know exactly what the price is. Although some people have. So we have raw helium down here at $350 per 1,000 cubic feet. That's a US number. And then we have refined helium up here in the $600 range per 1,000 cubic feet for 99.999% pure helium. So the big messages here are that in 2013 through 2018, helium came off the market and the price stayed relatively stable until the last sale, and then the price jumped immediately. There was no major changes in the world aside from the fact that the BLM sale stopped and then the price jumped. So when we look at price in the world, there's been a lot of debate you may have seen in the market. Is the price going to go up? Is the price going to go down? What's going to happen with the price of helium? So here are a couple of comments from my perspective on the price of helium. First of all, North America accounts for about 60% of all the helium consumed globally. So it's a significant player in that space. And 2.1 billion cubic feet a year were removed from the US out of that 6.3 billion cubic foot demand from the market as of 2018. So we're in Canada and we're looking to sell helium into the United States, obviously. So the price is going to go up, the price is going to go down. Well, a couple of things about helium. I think the price is going to stay high, and I think there are 2 major reasons for that. The first one really has to do with economics. So what we have a situation right now is the price went up dramatically. It's not necessarily a supply-driven thing. So it's we have a situation where there is economic rent to be captured in the market. And we have a situation where there are 4 companies that I mentioned that basically control 80 to 85% of the global market for helium. So there's an oligopoly on helium, which means it's there and extra economic rent can be captured. So it's not necessarily a free trade situation. What could cause it to change into a free trade situation is a supply increase in the world. Well, the other places that supply comes from in the world, helium comes from in the world, is Qatar. About 30% of the world's helium goes through the Straits of Hormuz, and Algeria over here. And you have read that there's plants coming on in Russia out of the Amur project, amongst others, and large supplies coming on stream. So with regard to Algeria and Qatar first, both of these are based out of national oil companies, and both of those national oil companies are partnered with ExxonMobil. So there's really still a relatively small group of players that are controlling large volumes of helium in the market, and there's no reason why they would want to give up economic rent. So unless Russia decides to flood this market or the rest of the world market with helium and try and hold control that way, it's unlikely that there's going to be a sort of a competitive market for price. And so we're unlikely to see supply and demand driven by simple market dynamics. That being said, and Russia is unlikely to give, why would it want to give up the economic rent? So there's the economic rent argument. That's one argument. The second argument, I think, is actually the more compelling argument, and it has to do with the nature of helium itself. So as I said, helium is the last thing to become a liquid. Well, transporting and storing something that has to remain just 1.15 degrees above absolute zero is a bit of a problem. In fact, it's a big problem, and it's a bigger problem than it is with liquid natural gas, which we also see out there in the world. So let's talk about liquid natural gas just for a moment. Liquid natural gas is sold out of Darwin into Australia, into China rather, for about $10 an MCF. And so the guys down here in New South Wales pay $10 an MCF for their gas. So we're over here in Canada, and we can't get $5. Well, we can now, but $5 for our gas because the Permian Basin produces so much gas that it dominates the market. Well, the transportation of natural gas around the world globally has enough technical challenges that US is not flooding the market in China, and we don't have supply and demand. The point is that we have localized markets because of the nature of the commodity. We have the same problem with helium because helium needs to be transported as a liquid. And this is how it's transported. It's transported in something called an ISO container. And an ISO container looks like this. And it basically is a container, it's 40-foot container. And it gets transported on container ships. It holds 1.1 million cubic feet of helium. And what this basically means, and that it has a 40-day shelf life, so 40 to 42 days. So think about that. Container ship. There aren't ships that are taking containers around the world. We know that there's a container ship crisis going on in the world. Somebody out there has containers that are stuck on a ship someplace, and after 40 days, it starts venting its product. That's a loss situation. So this is the challenge with helium. It's transported as a liquid. Keeping it stored as a liquid is a real problem. What happens is it gets stored. It goes to essentially what they call a trans-diff station, where they basically transfer it and make it into a gaseous product. And then it gets transported out or put into bottles or put into dewars, which are those silver containers you see in the edge of MRI room that have actually the liquid helium in them. And that's how it's transported. So it's an on-demand product, and we see localization of the market price. So between the economics essentially of capturing that economic rent and the fact that it has localization of the market, I think we're going to see maintained higher prices for helium in the marketplace for the foreseeable future. So Alberta. Well, helium people have been looking for helium around the world at different times around different drivers, and Alberta's no different. And this is certainly true in other countries around the world. This is the one that I can lend my hand to at this moment. So pre-1930s, there were discoveries made in Alberta of unburnable gas. And those gases were predominated by nitrogen and other things with little bits of helium. In 1930, the British built a blimp, and it was called R101. And they experimented with using hydrogen because helium was rare and very expensive and from the United States. And it blew up. So when traces of helium were found in Alberta, there was excitement in the empire, and the search was on in Alberta, and that lasted for a little while. The Germans then tried the hydrogen-filled experiment again with the dirigibles, and that's the Hindenburg, and it blew up. And so the search was on again for helium inside of Alberta. And then things died down for a little. World War II began, and so anything that keeps things aloft is important, and helium is an important resource. And there was a big blowout in Alberta. And I'll show this in a second, but that blowout in Alberta basically had an unburnable gas to it. And that was the Steveville, and it could become a helium producing center, because remember, at this point in time, Texas has a monopoly on the world for helium. Then everything goes quiet for a long time. And in 2013 to 2018, we see the price history that I described for you, and helium becomes important to the world again. And so we begin to see the development of the industry. Several early leaders in this area were Whale, who picked up on the of unburnable gas in southeastern Saskatchewan. They've since been followed by North American Helium and Royal Helium in Saskatchewan. And Thor is actually producing helium in Alberta right now. So with the price jump, some early sort of the groundbreakers got out there and started looking for helium. And really, we're just part of that beginning motion out there. In 2021, Canada woke up, said, whoa, helium's a critical resource. And they declared it as a critical resource, which was great. And then in 2021, Alberta also woke up and said, okay, helium's valuable. So we'll establish a stable environment for it, and we'll fix a royalty. And fairly, because as Albertans, there should be a royalty on our product that comes back to the people because we own the resource. So the scale of the opportunity. So where is helium found? Where does it come from? Helium is actually the second most abundant substance in the universe. And it's that because it's a product of fusion, and fusion from the sun. So about 25% of the flux that comes off the sun is helium, which has nothing to do with the helium on Earth itself. Helium on Earth basically is generated as a product of radioactive decay. So in radioactive decay, something called an alpha particle gets thrown out. And the alpha particle has 2 protons and 2 neutrons. And it goes out and it grabs the first 2 electrons it can find, it becomes helium, and then it stays inert forever. But what it happens is then it's extremely light and small, and it begins to migrate up through the Earth. And as it migrates up through the Earth, it bumps into hydrocarbons, which is why you often find it associated with hydrocarbons in the world, and why you also find it associated with gases where there are other gases that are coming out from the Earth in higher concentrations as well. So when we look at Alberta, so for those of you that internationally speaking, Canada, the resources are owned by the country itself. So the government owns all the resources, which means all the data from all the well bores that are drilled also belong to the government. And those are in public databases. They remain proprietary for a year or 2, and then they become available to the public at large. So this is the province of Alberta and BC off on this side. And in this map area, 645,000 odd wells have been drilled in what's known as the Western Canadian Sedimentary Basin. 189,000 of those wells have got gas analyses. So we know where the gas is. So when the gas is about 0.5%, there's about 2,000 wells. So this is the distribution of wells in Alberta that have more than 0.5% of gas. So why would 0.5% be of interest? Well, a really good well in Alberta, a really good well in Alberta these days would be about 10 million cubic feet a day. Now, helium occurs in small concentrations. So 1% helium would be a good concentration. 1% helium times 10 million cubic feet a day is 100,000 cubic feet of helium. At a very low price for helium of $250 per 1,000 cubic feet, that would be $25,000 a day of revenue stream, or 365 days a year, $9.1 million a year. A helium separator, which I'll talk about in a minute, costs around $4 million to make. So it's a good piece of business, hence the attraction to helium. Now, there's a lot more problems to it than that, and it's not that simple. Most of these dots that you see on here, some of them are depleted wells. Basically, it tells you that the helium has migrated along the pathways that hydrocarbons have migrated along before, and they become trapped with hydrocarbons where the seals are really good, because remember, helium is the smallest molecule. This is where the Steve will blow it is down here, and where we're progressing forward. So this is a picture from 1940 from the blowout, and fist-sized rocks pinging off the steel derrick, sparking, then flying high. Well, basically a large cloud of gas formed around this thing, and everyone was terrified that it was going to go boom, and everyone would get burned. But that never happened. And when they got the well under control and actually did a production test, they found out that it produced about 6 million cubic feet a day, and it had 0.63% helium. We've gone back in, we've captured the asset. It's a large basement structure. And I won't go into a lot of detail, but we've discovered that the helium concentration is actually 0.43%. And we have production rates of 5 to 8 million cubic feet that we can sustain on one well for at least 3 years before we begin to get to decline. Conventional reservoirs. That's what we're dealing with here. What's important though for you that are out there evaluating helium, I want to raise your attention to something. Helium is measured, you'll see measurements for helium, but there's two ways to measure it. One is a passive way. And in the passive measurement, basically a gas chromatograph is using helium as the carrier gas. And so you take 100% less everything else that you've got, and whatever's left over, that's what helium is. Okay, so it's sort of a leftover analysis approach, and it's inaccurate. So when you see high measured values of helium, please take a look and see if they're real. The other way that you measure helium is by using argon, another inert gas, as the carrier gas in the gas chromatograph. And then there's an active measurement of the helium, which tells you exactly what the helium concentration is. And that's really the preferred approach going forward. And that's what we've done here as well. You'll see there's no ice in the picture. We have very low liquids, less than a barrel per 1,000 cubic feet. And we're planning to drill a second well, and we'll expect that our guidance around this is basically that we'll have 2 wells that will be producing 10 million cubic feet a day. And we'll be going forward with our initial plant by the end of 2022. So how are we doing that? Well, what we've done is we've formed a strategic alliance between On2 Solutions, who is our company that is building and fabricating the plant. We're building a prototype plant. This is just a small plant that proves that we can actually do this. And Uniper Trading Company, who is our gas offtaker. It's not one of the big fours, but they're interested in entering. They're like Trans-Canada Pipelines or a major power transporter, but they're based in Germany. So this is how the separation of the gas works. And it's really not too complicated. So gas comes from the wellbore. The first thing we have to do with that is dehydrate the gas. So take all the water, gas. There isn't a lot of water in this particular gas. We do have CO2 in our gas. So we use an amine unit. And the way this works is basically the gas is passed through amine. The amine picks up the CO2. Then it's circulated around. The amine is boiled. The CO2 is liberated, and then it's taken out, and it'll be taken out, and then it'll be basically pushed back into the ground in a disposal well. So we're carbon neutral from a CO2 perspective. Then the gas will go into a helium separator, and I'll explain how the helium separator works in a moment. We will then what will come out of that is nitrogen and methane. So our composition on our gas is essentially about 90% nitrogen. It's about 8% CO2. It's around 4%. About 4% methane, and we will take that methane and we will use that as fuel gas. And then the helium that comes out basically goes into the loading facility. And here's the thing, helium is this small volume, high value commodity. So the custody point is at the end of the plant, and it gets compressed and put into these things, and they're tube trailers. And each one of those is a steel tank, and it looks like a scuba tank because it holds about 3,200 PSI, the same kind of pressure with a scuba tank, only they're 53 feet long. And there's like 6 or 7 or 8 of them stacked onto a trailer, depending on the volume of the trailer. And each trailer carries about 200 to 250,000 cubic feet of helium. And then it gets trucked off to market. So here's basically how the separation process works. Helium comes filtered in, dry gas, and then it goes into something called a mole sieve. And a mole sieve is nothing more than a molecular sieve or a molecular filter. And that's all it is. It is just a sieve. It is a membrane through which only helium will pass. So raw gas is on the outside. Helium passes into the membrane in the center of these little straws, and they're taken off. Now, like all sieves, they leak. So you can only get to about 90% pure helium in this process. The waste gas, of course, goes off, nitrogen gets vented, methane used for fuel. And then to get to 99.9% pure, I should stop there. A lot of gas that comes off this could go off to as raw gas for balloon gas. You can get to that kind of levels in this process. After that, if you want to polish the gas to get to 99.999% pure, because remember, raw gas sells for 300 and refined gas sells for like 600. So there's a big delta there in terms of the margin to be caught. To get to 99.999% helium, one of the things you go through is something called a vacuum pressure swing adsorption. And pressure swing adsorption. Now, helium is inert. So its separation process is a mechanical process. It's not a chemical process. And the way this process works is it works like it's an electromotive force. So it's like rubbing your arm and then sticking a balloon to it. What you basically do is you have a chamber and has zeolite in it, place, and you run an electric charge through it. And then anything that carries a charge, like CO2 or nitrogen or methane, adsorbs onto the clays. The helium passes through. Then once all the adsorption sites are filled, you basically switch some valves, purge the chamber, turn off the electricity, purge the chamber, rinse and repeat. Pressure, swing, adsorption. That's how it works. And it's pretty much that straightforward. There are, of course, nuances to it because just not everyone can do it. But that's how the separation process works. So when we look about some of the issues that are facing this evolving industry, there are things that we come forward with. From the investors, it's knowledge. It has irreplaceable uses. It is absolutely valuable, hugely valuable. It is largely an unknown commodity. Most people really just think it's kind of a balloon thing. But we're in a situation right now where we have opaque supply, we have opaque demand, and we have opaque price, which makes it a very difficult market for investors to read. From the markets themselves perspective, there are regulation issues. So the governance is non-explicit at this point in time, and that's because it's new as a critical resource in Canada, and it's new in terms of a commodity. It's not like it's a traded commodity everywhere. There are no spot prices for this. That's because there's no large places to store helium around. It's an on-demand product, so it's traded as an on-demand commodity. The end result is that there is no compliance for NI 51 or 43101 in Canada. And these are basically the regulations that say, okay, you need to show how much resource is there so the investors all know what that is. Nor is there a resource classification like the SEC has set out for natural gas, or for oil and natural gas. So there's nothing that says a prospective resource is that thing in the ground, which is a good idea, but nobody's drilled yet. And a contingent resource is that thing in the ground where someone has drilled a hole and we know what production rate will come out. Nor is there anything that says if it's a reserve, we know that it's in the ground and you can get it out, but there's a commercial contract that says that it is actually a commercial entity and therefore it is reserved. None of that exists for helium right now. So when you see volumes of helium and what companies have for helium, you need to interrogate those thoughts and ask them what they've got. These are some of the issues that we see in terms of investors and markets. Now, with respect to governance and governments from a Canadian perspective, and also internationally, helium is really just in its infancy. And it's moving from a place where it was dominated by the US market and the sale in the US market to a place where its supplies are coming from other places in the world, and countries and companies are beginning to figure out and navigate that space. So this is very much an emerging market. It's an emerging commodity, and there are emerging government things about regulations that need to catch up to where we are. So with that being said, I'm going to pass it off to the guy that really knows about all that stuff, Tony, and let it go forward from there. So Curtis, I'll pass you back control, and on we'll go.
Thank you, David. That was very interesting. I certainly learned a lot on the helium there. I'd now like to introduce Tony Chione. Tony has built an impressive career in energy law, specializing in domestic and international exploration and production development. With more than 2 decades of international experience, Tony's work has touched 40+ countries. His foreign language skills in Russian, French, and Italian, combined with his international petroleum sector experience, make him a dynamic leader in energy law. He's called in Alberta and England and is listed for Energy and Chambers and International Who's Who. He is currently a board member and the secretary of the Association of International Petroleum Negotiators, AIPN. Please welcome Tony Chione.
Thank you, Curtis.
I will give you control.
Great. I did notice the entire panel this morning has matching team haircuts. Okay, so I've got control now, I believe.
Yes, just click on your screen.
Yeah, got it. So I'm going to pick up where Dave left off. As Dave noted, helium is it's an industry that's been around for a long time, but it's quickly evolving lately on the back of a supply need, particularly following on was sort of the slow-moving results of shutting the BLM program down as a government concern in 1996 during the Clinton era. And so anytime that you see this much change in a market, there are naturally a number of legal, commercial, and even political considerations, to plot out while you're figuring out where and how you'd like to do business. So I'm going to take a quick exploration of that. So calling this legal and regulatory, I think the first comment off the get is that these things are highly recombinative. So, a regulatory issue in oil and gas, for example, often relates to operational matters relating to well-known industrial processes, et cetera. When you step into a brand new industry and the operational components aren't necessarily clear, or regulators are not very familiar with the tenets or the dictates of the industry, you get some funny outcomes. And that's definitely a trend we've seen in working with Imperial as counsel and also as commercial advisors on occasion. So, when you zero in and look at, for example, the Alberta experience, but I think this gets replicated in a number of different jurisdictions, historically minerals management has been focused on oil and gas. And so you have an entire regulatory scheme, including, a government org chart that's really set up for the purpose of regulating one thing, when in fact, they've got to figure out how to regulate another entire thing. And so that does tend to bake in a biased perspective in terms of how governments approach regulation and law. And so to give you a brief international example, like if you looked at, we'll pick any country, like Brazil having the ANP, or Colombia having the ANH, those are the government organizations tasked with regulating the oil and gas sphere. Do the ANH and ANP constitutionally actually have authority over helium? That's an open question. And even if you look at AER in Alberta, realizing that helium itself is not an energy source, does the AR really have the ministerial authority, even though the AR may be governing, tenure and operations for petroleum, natural gas. That's a segment of the subsurface. So you get this very mixed picture. And, when you look at the technical nature of this, on tenure matters in particular, you then realize that some of the time helium is found with methane sources. As Dave iterated, Imperial has some source of methane, but it's largely not a natural gas reservoir that they've tapped. There will be cases where the helium molecules are absolutely found in natural gas streams, and we'll talk about that being the case in places like Qatar and Algeria. But what if the helium's found in other resources such as nitrogen gas? So you then get into this potential for tenure issuance problems, which is, well, if I get a petroleum and natural gas lease from the Crown, does that include the right to produce helium or exclude it? And there will be mismatches all over the place, depending on jurisdictions. There is a high potential for what we would call trespass, which is essentially, well, what happens if you start producing one substance and along with that you produce another substance, but that substance doesn't belong to you. So these are the things that people have got to watch out for. And in relation to that, if you only have one tenure instrument, let's say a lease, a natural gas lease, but that lease could be used for the purposes of natural gas and or helium production, then you're placing a government in a position where it has to coordinate the use of that geologic resource by a number of different people who have different purposes for it. So anytime you coordinate different interests, well, we can talk about commercial coordination, but that is the sausage making that is politics and determining what interests should come before what other interests. And so, we do see that as a developmental pattern, the story to come. I'm sure if we sit here a year from now, hopefully we can time date that Tony and Dave told you in October 2021 that this might be the case a year later, but where's the intersection of interests between natural gas, helium, lithium extraction, and you could probably add carbon storage to that same question. Of course, the CO2 injectors are looking to use that geologic resource for a very different purpose, an injective purpose, not an extractive purpose. But again, you have multiple purposes relating to the same geologic resource. So, this does tend to set up a bit of a potential car crash. And just as an example of what that might look like, I'll let it as a live example that we're working on today. We have good information that the province has made a reservation of a large swath of land, about 20% of the province by my reckoning, locking up geologic resources for the potential of using them for CO2 injection. Now, I don't sit at cabinet ministry table, so I don't know the exact nature of that discussion, but I could imagine it would have something to do with, for example, carbon sequestration from oil sands operations. And so, if the province were to permit the use of that geologic resource for sequestration, what about the helium producers? What about the lithium producers? So this is a live issue that we're working on right now. In fact, if anybody's interested in hearing more about that, I would encourage them to reach out to Dave or myself, as we are trying to pull together common interest groups for these alternative uses. And when I say alternative uses, I actually think I would put independent CO2 injector businesses on the same list because we don't know where the province is going with this. You know, so that's a major issue. And as part of that package, we're also looking at creating the International Helium Association. This may be surprising to hear, but there is currently no international or even domestic industry association for helium production. Given the opaqueness of the interests of the industry itself, that's sort of surprising and not surprising. I think there are some actors in the industry that would perhaps not encourage the sharing of information as much as others. But we've undertaken that. And so again, if anybody's interested in that, and I'll give some further details in a minute, please let us know, because I think that will play a role in mediating this discussion with the province about this reservation of rights. So that's a sample of the kind of tenure issues you can get into. And you can imagine if you step from particularly common law jurisdiction to common law jurisdiction, you can imagine like problems arising. I think in the international sphere, as we'll discuss in a minute, where an NOC basically has access to all the subsoil resources of a country by dint of the Constitution, it's a much flatter looking regulatory situation. So then carrying on, I thought I'd just give a quick sample of some of the biased perspective operational regulatory issues, just to give you guys a flavor of, you know, what is it going to look like to try and manage this growing business in a place like Alberta or Saskatchewan, for example. So we will all know about drilling spacing units, basically being a broad thumbnail for reservoir conservation. I think it's 1 well per quarter section is the max. Now, you know, when you, that's a thumbnail limit or delimiter on, let's say, gas production. The problem is that may make sense as a thumbnail for natural gas production, but does it make any sense at all if you're talking about helium resources or helium resources produced from a nitrogen reservoir? So, you know, this is as a biased perspective, DSUs having been developed over 60, 70 years to deal with a conservation issue relating to, you know, hydrocarbons. That foot, the shoe doesn't fit very well on a different kind of foot. And that's also true of the unitization and pooling process, where, as we know, daily people can make application in the AER to pool resource if there's reservoirs in communication. That's sensible reservoir conservation management on the hydrocarbon side. But if you take that same set of rules and apply that to you know, a field with helium and natural gas, does that make sense? What happens if you combine it with helium and nitrogen? Does that make any sense at all? So we've got these rules clunking around that have serious commercial output or impact, but without any real examination of what those rules look like when they apply to things other than hydrocarbons. I'd mentioned mineral trespass issues. You know, that let's take the provincial crown example, where the province has a giant reservation of rights and creates CO2 injection hubs. And those hubs inject CO2 directly into the same geologic reservoirs or resources that are shared by some freehold owners. If that reservoir gets filled up with CO2 and the helium or the lithium prospectivity disappears because it's been sterilized by the injection operation, well, someone's going to have to pay. So we see that as a bit of a car crash coming for sure. And then the final point I was going to make here, which is sort of the obverse of the bias perspective, where oil and gas, as we know, oil and gas regulation has long had classes for common carriers or common processors. We're well past the Standard Oil universe of the 1890s, where, if you wanted any refining or transportation capacity, well, I'm just going to take your asset. We've moved obviously into a public regulatory environment where there's open tariffs, and regulators tell you, how much capacity you may or may not be able to get access to. None of those common carrier rules exist for any of the helium infrastructure. So, that's more taking a step back in time to the commercial animal that oil and gas probably was in Alberta in the 50s. And so I wonder what the trend will look like there. So that's just a flavor of regulatory issues, Alberta-centric. Mind you, they'll be the same issues you're going to find in any jurisdiction which has had a history of producing oil and gas and which has helium prospectivity. My last information slide speaks to geopolitical issues. Dave did a great job giving an overview of who the other players are. But from a commercial and geopolitical perspective, it's important for new players, I would say particularly smaller players in North America, Canada, US, and Africa, which is where the smaller players tend to be right now, that there are larger forces out there that sort of determine or have the potential to determine in part what pricing looks like. And so if you take a trip back through time, as is evidenced by this chart, in fact, if you go right back to 96, when the BLM was essentially privatized during the Clinton administration, the first helium players out of the gate were actually Sonatrach, who brought on, I believe their first helium production project was at Skada. You'll often see these projects linked to LNG. Why would that be? Well, you're already taking large volumes of natural gas and doing the liquefaction process, bringing their temperature down. So for an additional increment, more of CapEx and then obviously OpEx, you can then knock helium molecules out of the stream. And so what we found, if you look around, that was the model that the Algerians first engaged in. They actually have a second plant that is up and running as well. The next players to come in internationally were the Qataris, who also followed the same model of absolutely massive volumes of gas with liquefaction. So these are not the kind of numbers that David been mentioning where, 5% of production content or 2%. We're talking about 0.4%, 0.5%, but the volume is so big that it still generates an appreciable amount of helium sales gas and or liquid. And so if you look at the trend then, Algeria comes out of the gate to replace essentially some of the BLM slack. Then the Qataris enter the market and start making their own splash. And now finally we have the Russians coming into the game with the Amur gas project, particularly as it's called Amur 1, 2, and 3. The Russians have just built on the Amur River, one of the largest gas processing plants in the world. And I do believe in their joint venture with Linde out of Germany that the helium side of that plant is the largest helium production facility in the world. It's also playing the same game that the Algerians and the Qataris are playing, lower percentage content of helium, but with massive gas volumes. And the clear play for the Russians, as Dave pointed out, was, they have dock access to the Amur to the Amur project on the Amur River. So the Russians will be able to offload into ISO containers direct to maritime transportation, and then probably largely servicing Asian markets just due to proximity and transportation cost. So the Russian share of the market will probably grow to something like 20 to 30% of market share in the next coming years, depending on whose projections you look at. So that's the end of the informational part of the presentation. As I had mentioned earlier, for those who are interested, we are setting up the International Helium Association. In fact, CEDO, my firm, we've created the legal entity already, and we're at the point where we are looking for co-founders, corporate co-founders in the mode of sponsorship to help really set this thing up and get it launched. Our intention is that the members of the association will be individuals, not businesses, to sort of democratize its operations. But if anybody's interested, again, please drop Dave or myself a line here. I'll put our email addresses below. Or worst case, if you forget to do that or take a screenshot, feel free to pester Curtis whenever you like, and he can connect us. So Curtis, that's all I had, and I think we've got on tap preparation to move into the Q&A.
Yeah, thank you very much for that. Interesting to hear about the regulations in Alberta and some of the competitors worldwide. There are a number of questions that have come up here, and I'll just ask them, and whoever is the best person to answer, just feel free to speak up. Now, one of the things that came up was the prices for helium. You say it's a pretty opaque type of market. Do you see that changing at all?
No, I don't see that changing at all. I think most of the contracts will remain company to company, that they'll be locked behind non-disclosure agreements, and the price will remain relatively opaque until it actually becomes sort of a traded commodity. It'll remain opaque.
Okay. One of the things, of course, in Alberta here, we're have had difficulties over the last few years with oil and gas industry. How transferable are the skills from oil and gas industry into the helium industry?
They're directly transferable. Tony's outlined a lot of the legal components to this and the business components to it, but from the sort of the boots on the ground perspective, it's still a drill pipe. It still requires production testing. All those processes are the same. It's really just comes down to the plant separation process, which is different, the actual helium separation.
But I might add to that, on the service end of things, which I think is going to be part of the audience here today. Mm-hmm. As Dave points out, yeah, the resource comes out of a pipe. So if you know how to drill pipes, that's a head start. Certainly the processing, there's obviously a bit of science there with some specialized EPCs around, but wrapped around that technology is a lot of the same skid mounted equipment that oil and gas operators have been using for years. So I do think there's an opportunity there for Alberta companies to pivot from pure oil service to, other service.
Absolutely. I that's well said. I mean, we've drilled 2 wells. We've recently used standard oil drilling services out of Brooks and the Red Deer and the surrounding region to do the work with. Eventually we'll have a plant in place and we'll have service plants, just like everywhere else, have got to be run, and they need staff 24/7. And we have wellheads that have to be visited, every day. I mean, these are the regulations inside the province, and so yeah, it's going to put people to work. It's another industry that puts Albertans to work.
Very good. I have a question here from Atul. David, do you think there is potential for helium-driven exploration rather than being co-produced with natural gas? I recall Helium 1 was exploring for helium only in Tanzania.
Yeah, and that's what we are. We are a helium exploration company. We're looking for helium. In Alberta, there is a lot of helium that is produced with natural gas. I'm certainly not going to say no to the opportunity, but the focus for me is on helium. I only have, as I said, 4% natural gas in my gas stream, so there's nothing economic from the natural gas side for me. It's just, I'll just use it for fuel gas, that's all.
Yeah, and then maybe to respond to Atul's question, that's one model, but helium, because of its nature, affords a few different potential models for exploitation. So on the other end of the spectrum, from looking for the one magic nitrogen reservoir that has 8%. On the other end would be the ginormous capex involved projects that you see in Algeria, Qatar, and Russia, where there is just gobs and gobs and gobs of gas, and you're playing the volume game. And then that game is obviously, that's more of a capex risk tolerance game than a geologic.
Yeah, their concentrations are really low. I mean, you mentioned 0.4%, but it's actually 0.0%. I mean, we're not really small, but massive volumes. And that's where the value is. In Alberta, we're dealing with ranges in sort of well, I'm using sort of, I have 0.43, North American helium in Saskatchewan is 0.4. And those volumes make sense, as I said, sort of when you get into that 10 million cubic feet a day kind of range. So it's very much a volume concentration story.
Yeah, and there's probably parallels, I would say, between the large end capex play and, let's say, oil sands, where you actually know the resource is there. The question is, do I have the capex wherewithal to build this thing, and will the economic bet pay off?
No, it's like taking silver out of a nickel mine, or in that case, silver out of a nickel mine, or gold out of a copper mine. It's the same thing. It's the value-added product in those cases, but there's enough strength in the price of the commodity and the demand of the commodity for itself to be the thing that you're looking as the primary, and where natural gas, I think, in Alberta is a good sweetener.
Thank you very much. David, you showed a picture of a semi-trailer with a number of bullets on it there.
Yep.
Once charged up, what would each one of those bullets be worth?
Oh, I don't know what each bullet would be worth. So, one of those trailers would hold about 250,000 cubic feet. So that's 200,000 times 500, so $100,000 worth of product on one of those trailers, round numbers.
Okay, that's substantial.
Yeah, I mean, one of those ISO containers would be like $500 million, $500,000.
Okay,
$500,000. Yeah.
Another question in here is, in oil and gas, we talk about full cycle finding and development costs. What is the reasonable F&D dollars per reserve for helium exploration and production?
I don't have one of those for you.
Okay, fair enough. A question for David, for me actually, is that there are two main isotopes of helium, the H4 and H3. Are there different uses, and what is the price difference between the two, and what's the concentration?
Yeah, so So helium-3 and helium-4. Helium-3 has one less neutron. And helium-3, so helium-3 cools at becomes a liquid at a much lower temperature. It's like 0.1 degrees above absolute zero. So very, very close. And so it could have great uses in terms of quantum computing or in terms of stabilizing temperature. So in quantum computing, you have to get down to the place where you can keep the electrons stable at one elevation. That's how quantum computing works, is by isolating the way the electrons are stabilized. To do that, you have to use helium to get the temperature down low. If you're using helium-3, you just take probably some fluctuation out of the system that you see with regular helium. So there's that. Helium-3 also can be a fuel. So people may have seen news articles about people going to the moon to get helium. Well, they're going to the moon to get helium-3. And the idea here is that you take helium-3 and you put it in a fusion reactor, in a Tomac reactor or something like that. And you hit it with a neutron, and you create helium-4 and you release a ton of energy. So there's in the fusion process, you create this huge amount of energy. So there is future for it as a fuel as well. It occurs extremely rare on Earth, sort of points and points and points of percent. I'm not sure exactly how much it is, but we're looking at basically a value of helium-3 of $16,000 a liter. Okay, we're talking about orders of magnitude difference. And it would be on Earth, it probably is generated as part of a primordial gas that is finding its way out of the Earth. In space, it is basically a product of the fusion reaction from the sun. It travels through space as space plasma, and some of it is captured in the moon, which has no atmosphere and hasn't filtered out the helium-3. So hence the reason why people are looking for helium-3 on the moon in terms of the moon rocks and resources that are up there. And this is some of the things, but there's huge value in helium-3. Most of the helium-3 that we have on Earth, aside from what I've just mentioned, is found associated with arsenals of nuclear weapons as a byproduct of those. So it's quite a controlled product.
Okay, good.
There is a interesting value flag for that, which is Dave recently sent me an article about the proposed space elevator to the moon to mine helium. And so, being a dumb lawyer, I was like, well, I wonder what the space elevator looks like. It was just a thin carbon string that orbits the Earth, is attached to the moon. And then by solar panels, a mining cart essentially that would take, helium mine off the moon and bring it into Earth's upper atmosphere, which is sort of then the really expensive part to get it down to ground. But what fascinated me was the projection that the entire elevator system would be repaid off the first load. So this starts to give you some specter of risk reward opportunity out there, that attaching carbon filaments to the moon with insane solar mining carts, like if you only got 3 loads out of it, it's obviously going to be worth trying. So I think we are going to be stepping into some, the next 30 years are going to hold some pretty amazing things to come.
So people in the future will actually be horrified that we ever used helium for balloons.
Exactly, exactly. I got time for a couple more questions. One is, when playing with really low concentration, how is the comparison between drilling for helium and separating helium from air?
Oh, helium in air is, I don't know what the concentration is in the air. But it's really small. Background helium that's coming just in almost any well that you find in Alberta would be 0.0002%, 2 to 3%, 1 to 3%, that kind of range. So that's what's coming out, just sort of finding its way up through the surface. So it's in sort of that sort of care that, and you'd be processing staggering volumes. But the point is correct, in that helium is light enough that it is not held by the atmosphere. Once it's found its way to the surface of the Earth, it will find its way through the atmosphere and out into space.
Okay, one last question. I think Tony might be a good one for this one. Do you think the current anti-petroleum sentiment will affect the potential for the large-scale co-production from natural gas in Alberta?
Yeah, this is probably the point of the proceeding where I'm about to be canceled for something that comes out of my mouth, but
Well,
I'll
take it easy.
happily play this guy. Well, you know, I think primarily it is not an energy business. And so as Dave noted, sure, there's a small amount of methane that comes out of his development, for example, but there will be many examples of companies that are helium extractors that don't have much to do with oil and gas at all necessarily, except for the operational similarity of drilling a hole in the ground, right?
Yeah.
So that would be my first thought. Large scale co-production in nat gas from Alberta. This is where I might put on my Alberta taxpayers hat, and you know, why aren't some of those molecules being captured now? Like, we're literally wasting a public resource. I find that embarrassing, especially at a time where you know, we could use every dollar in the treasury we could get.
Yeah, to be clear, that's 12.1 million cubic feet a day of helium is vented with gas production in Alberta.
Right.
It's just led into the atmosphere.
Yeah. And so who's got it? I was going to say who's their hand on the tiller, but clearly no one does yet. So this is the kind of thing that, you know, if we get, as we form IHA, would be one of the discussion points. You know, having said that, yeah, there could be anti-petroleum sentiment, but I think natural gas has been clearly identified in the Paris Accord as the transition substance of choice. I don't know how in the public dialogue that ceased to be the case when that was always the actual design in the first place. But the fact of the matter is, as we're now seeing in Germany, for example, yeah, you're going to need that for a while. And I think our only point is, well, what about this other resource that's being wasted? But this goes back to tenure right issues. So if there's any midstreamers on the call thinking, oh, that's great, I've got all this gas and pipelines and I can separate it out. You know,
who owns the molecules?
Exactly. The disruptive point is you're here to transport someone else's molecules. So actually, who owns those molecules? And then a producer will put their hand up and say, well, I have a lease from the government. They're mine. But if your lease doesn't clearly cover helium, are they still the state's? Like, it's a mess. And I do find it just to be slightly critical of the government for a little bit. That the thing that they did a few years ago is to bring in a royalty for helium without looking at all of the other tenure issues and regulatory or operation issues. It's sort of like they just skipped all the way to the end without actually creating the legal framework for certainty, the likes of which markets like to inject capital, right? So thankfully, Dave's not on Crown land, so that's, you know, 2 thumbs up for Imperial, but this will bite at some point. So
yeah, no, listen, Imperial, not Imperial, but helium is an easy win for the province. We're like mining for gold, all right, and finding gold. It's there. It's a small commodity. It's transportable. It's highly valuable. It's using industry that already exists. It puts people to work. It provides royalties for the province, and they're royalties that are significant. There's a easy win here for the province, and I can't say we've had a lot of luck getting traction with the government yet, and I'm looking forward to that. Had some conversations. They're very interested to hear, but we need to see some traction.
Well, it's a work in progress, and at some point, well, obviously, it's going to have to work its way through the system, and the regulations will come in at some point. It
Well,
looks like we're almost out of time. Sorry, Tony.
Oh, I was just going to add, you know, the thing about the reservation for CO2 is an example of what I would call the petroleum bias, in that you view all of your resource base to be in service of one thing without considering all the other things that go along with that resource base. So I think that's just part of that historic perspective problem.
We've just been oil and gas for a very long time.
Yeah.
And we have to change.
Yeah, if you're a carpenter, everything looks like a hammer and a nail, right? So so if anybody's interested in changing that dialogue, like I say, give us a ring. We're going to need many hands to lift heavy.
Well, good. Well, thank you guys for the presentation. I know it takes a lot of time and effort to put these things together. I'd like to take the opportunity to thank our speakers. This is an excellent example of how engineering and geoscience expertise and legal knowledge from the energy industry can be pivoted for use in other areas. CGEF would also like to thank our sponsors. It has been a challenging 2 years for many industries, and we appreciate the continued support. Future webinars are going to come up, and events. CGEF has recently released the latest report in our Global Opportunities Go series titled Creating Value, How Canadian Oil and Gas Companies Can Evaluate the Economic Profit Potential of International Investments. Now that's a mouthful. In this Go Focus report, we are excited to provide an introduction to an important topic for Canadian energy companies considering investing internationally. In support of release of this report, CGEF will be hosting a hybrid release event that will be in person in Calgary and simultaneously broadcast online on November 18th, just coming up in the next 3 weeks or so. So please take time to visit our webpage, cgef.org, or our LinkedIn page, where you can follow us to ensure that you're kept up to date with the release event, as well as upcoming webinars. I'd like to thank one more time all the participants, the over 200 people who registered from almost 30 different countries around the world. It's good to see a global audience like this, and exposing some of the Canadian expertise to people in other countries. And I'd like to thank you for taking the time from your day to participate in this event. And once again, thanks to the speakers. And until next time, please be safe, and goodbye to all.
Thank you.
Thanks, Tony. Thanks, Dave.
Thank
and
you.
that'll end our presentation for today. Thank you.
Take care.
Bye-bye.
Bye-bye.